If you remember on Friday, we were trying to actually debug an already deployed code on testnet. Meanwhile, it shouldn't have gotten to that if we had actually written test for it locally before we deploy to both testnet or mainnet. So we'll be covering the part where inside your code base in your local environment, you can actually test your code before you deploy to either testnet or mainnet. So that is what this session is going to be about. Before I continue, I'm utility, popularly known as utility in the ecosystem, and utility 6151 is where you can reach me on Twitter. So I'm also the co-founder of Fundable Finance. We do payment streaming, payroll on Starknet, and some other things. So today's agenda is going to be testing. What is testing? What are the categories of testing? Why do we need to test? What is the best practice? And then the tools for testing on Starknet. We'll also go into live coding. So we are going to test our token sales contract. If time permits us, we are going to test the Cairo program. So yeah, that is our agenda for today. Just like last week, I will try to make this as interactive as possible. I will not be able to see my Google Meet screen because there are two different browsers. So if there's anything you want to call my attention to, if there's any question, you can unmute yourself and just interrupt so that my attention can be called to the Google Meet screen. And at interval, I will pause to ask questions so that at least to be certain that you are following up. It can actually get lonely when you are doing the coding part. So what is testing? Testing is just the process of evaluating that your conditions are going to work the way you have thought or code that they are supposed to work. So without testing, there will be no need for us buying cars because why? They can't just manufacture cars and send it to us. That means it is going to be a disaster if they manufactured 100 pieces of cars without testing if the first particular car works perfectly well and according to specification. So imagine shipping 100 cars and all of the 100 cars are actually brake faulty. That means 100 people at the least are going to be dying or have a serious accident. So the essence of testing is to protect against this kind of scenarios. So where we just write the code, we deploy it just like we did last week. So we deploy the code, and upon getting to live environment, we realize that it was not working the way it is supposed to work. If we had tested perfectly well locally, we would have known that, oh, this is not yet fit for mass consumption, and there are still some areas that needs to be fixed before it is now actually deployed to testnet or production environments. So the main goal of testing is to identify defects, to verify that functions are going to work the way they are supposed to work, and also verify that the quality of the system we have built is actually very sound. So in testing, particularly software testing, there are majorly 5 types of testing and also applicable to Starknet too. The first one is unit testing. Unit testing is where we try to test, not line by line particularly, but a very tiny part of our overall infrastructure. For example, if we want to buy token, instead of testing the whole buy flow, we test if the user can send payment. Send payment is part of the entire buy flow. So if we want to test if the user can send payment or if we can even get user at all, that is unit testing. We are testing a tiny component of a particular flow. So we need to test line by line or maybe component by tiny component by tiny component, not overall. I think you get the mental framework now, right? We are not testing overall by flow. We are testing just a small part of the by flow. Can the user send payment? can the seller receive payment? You understand? The buy flow includes both of these things. The user send payment, the seller receive payment, the seller send goods to the user receive goods. So we test each of these components one after the other. Integration testing is actually now the all-encompassing test for that particular flow. So can we buy successfully? That is what integration test is all about. Buy successfully. So we test all the assumptions. And then we conclude that yes, we can buy successfully, because at the end of the day, the payment token moves from this buyer to the seller, and the selling token moves from the seller to the buyer. That is integration test. End-to-end test, as it is popularly called, is majorly about the entire flow of how this is going to work. Now we are testing, but then we need to mimic the point where the user connects their wallet to our platform. Once they connect their wallet to our platform, once they click send button from our or buy button on our platform, what happens? This is actually integrating the whole flow, not only the smart contract alone. The whole flow plus the UI plus every other circumstance that may actually happen in between the actual user interacting with our platform. So we are not going to touch that today, because that deals with building a UI and then owning a wallet, having a token, and using the user's token in the wallet to interact with our smart contracts. So that is end-to-end, from the beginning of the flow to the end of the flow. How it is exactly going to work in the real world is what end-to-end test is all about. Then first test. First test is a scenario where we test if some things can break. For example, if we are actually or mistakenly, we are using unit 8 for a particular function parameter, right? And then all of a sudden, we realize that things are breaking in production. Why are things breaking in production? Because some people are sending values that are more than the range of unit 8 to our contract. I think you understand, right? When people are sending value that are more than the large part of unit 8 to our smart contracts. So somebody wants to send a token, the highest part of our unit 8. Can anybody remind me of the highest range of our unit 8? Anybody? You know unit 8 is 2 raised to power 8 minus 1, right? Which should give us 250 watts.
255.
255, yeah. Let's assume somebody now decides to send 1,000 to our contract. You know that 1,000 is going to break the function, because our function signature only requires unit 8. So in first testing, we are going to send random numbers to our function to be sure that even if conditions we are not expecting happens in the wild, because people are going to use a lot of things in the wild. In fact, we used to say it a lot in software development, that the way we intend for our products to be used is not always the way it is used when it gets to production. People find unique way of using your product the way. So people might want to use it in a situation. So we use first testing to prepare ourselves for some of these scenarios where people can send a very large amount of number to our contract. And then fork testing. What about fork testing? What do we do in fork testing? Fork testing allows us to test live products without actually going live yet. In Starknet, there is this particular AMM known as a Kubo. Let's assume we are building a contract that interacts with a Kubo in production, and we want to test if the flow works perfectly. How do we test? This is already in production, and we are still writing our code locally. So we do what is known as fork testing. Fork testing allows us to copy the blockchain without interacting with the blockchain. It gives us the live blockchain, which we can interact with locally without changing anything on the existing blockchain. So let's assume in our testing or in our code, we have deposit function into a Kubo pool. You understand? And once we do that locally, it does not change the amount in the live pool of the Kubo. What it only affects is the fork part of the blockchain that we have available for testing locally. So I think you understand that distinctions, right? Unit testing, just a small part of a component. Integration testing, the entire components, end-to-end, the entire flow, force testing, testing with randomization, and fork testing, allowing us to test against the live environment. So yeah, that is what those things are about. Oh. So I've already talked about these things. So this involves testing individual functions or components in isolation, very focused on blah, blah, blah. So yeah, I've already talked about this. So for the integration test, you can test multiple components working together, involve multiple contract interaction. Mocking can be done when testing, and most of the time it is always fewer than unit tests, which is very logical because we have to test all of the functions all together, not line by line or small component of a particular function. So it verifies that interaction between different parts of the system works perfectly. End-to-end testing is the application from start to finish, as I mentioned earlier, majorly focused on the UI system integrate, how the UI system integrate with the smart contracts. So first testing him at finding vulnerabilities, unexpected behavior, as I mentioned earlier, it complements other testing units like test, integration tests, and it focuses on edge cases and failure points. Fork testing allows us to duplicate a live production environment for testing purpose. Yeah, so that is basically what fork testing is about. So why do we need to test? Before I go on, if you still have any clarification, you need any clarification on this type of testing, please let me know. I will go to the screen here and see if anybody has any question relating to that. Is there any question on the type of testing? Something that needs clarification? Awesome. So why tests? We test in order to identify and fix bugs, and then identify and resolve security vulnerabilities because money is involved. So if we have our token sets on chain and people can actually send us money without being able to get the token back in return, it leads to breakdown of the contract. So it verifies that our logic work the way we want it to work, and it ensure correctness and reliability of a smart contract. It builds confidence as a developer, and this part is one of the strongest points for me. Because once you start testing, once you start writing tests for smart contracts, and all your test passes, you feel the euphoria that, oh wow, this thing works the way it is supposed to work, and you get that fulfillment, some sort of accomplishment that yeah, you have done something correct. So what are the best practice for testing? So you test all public facing functions. You make sure that you cover both success assumption and failure assumptions, and also keep your test deterministic. As well, you should do most of the time, you should write lightweight tests so that you don't overcomplicate uh, things. So all public functions should be tested. Any function in your interface will be tested. Let me go back to the contract we wrote on. So all the functions in your interface should be tested. All of the public facing functions should be tested. And then we cover both the failure and success part. The testing tools available on Starknet, it is just majorly Starknet Foundry. So as Foundry is for Solidity, we have Starknet Foundry to test Starknet smart contracts. So there are a lot of tools that we can use to test our contracts. We get into them once we start writing code, and you will also get familiar with them once you start testing the Starknet smart contract on your own. So I guess that is the point where it is all theoretical. So I thought here that is the end where it gets all theoretical and it is time to actually write code. But before we write code, does anyone have any question? So if there is no question on the theory part, let's dive into writing the code. So let's start. Okay, so here. Can you guys see my screen?
Yes, sir, we can see it.
All right. So I want it to be as big as possible. So yeah, this is the contract that we'll be testing. This is the contract we wrote last week, Friday. For then, I want to share a link to our Starknet Foundry page. So when you start writing your test, this page will be very handy for you to be able to set up your testing and the rest. So all your tests, when you are testing your smart contract, will be in the test folder. So here you can have as many test files as possible. This is where the compiler actually look into to see if there are any tests for you to run. And I think will be test token 0.0. We're testing our token 0.0. So basically, what do we need to test successfully? We first need we need the cheat code provided by Starknet Foundry. We can go into writing tests and see what the data is all about. And network is too slow. Anyway, I just wanted to show you guys what it's all about, but we can start writing our code by bringing the type of contract address into scope. Contract address into scope. So because we definitely need it. We also need Starknet Foundry tools. This is Starknet Foundry. This is how we bring it into scope in our dependencies under your dev dependency in your scope.toml. So this is how we refer to it. We refer to it as SameForge standard. So here we come and say use SameForge. Okay. So we need a contract class rate. We need declare. All of this is coming from our Starknet Foundation. If you look at testing smart contracts, city network. City network. I think it's better here. So as you can see, all of this is coming from our Starknet Foundry, declare result traits, declare and contract class traits. Declare result traits. So that is all we have for now. Then we bring the contract we want to interact with into scope. Use, what's the name of our project again? Token says. token sales, that maybe token sale into option. Then you all know that you also need the tokens that mock. Then we have the token pay. What do we have in the token pay? We have the IUSDC. Can anyone hear me? Let me confirm. Awesome, thank you. We have the IUSDC dispatcher. We also need the IUSDC dispatcher tweet. So the still use token series. Mocks. Token B. The name of our tweet for token B. I block Fuzz lab. I block Fuzz lab token dispatcher. And I block Fuzz lab dispatcher tweets. I block Fuzz lab token dispatcher tweets. So we have these two. I think we have all what we need. Okay, we also need ERC20. Yes, anybody remember we brought Open Zeppelin contract into scope so that we'll be able to use composable contracts. This is what we did on Friday, bringing Open Zeppelin into our contract. So we also need Open Zeppelin. Open Zeppelin, ERC20. I think interface. Open Zeppelin token. ERC20 interface, and we need ERC20 dispatcher, ERC20 dispatcher, and ERC20 dispatcher tweets. Okay, I think I should do it like this. So basically, I think we have all what we need. We can also create the people who are going to, we assume the people who are going to be interacting with our contract. So we can do const owner. I'm very sure that you people have been taught the difference between declaring a variable with const and let in Cairo. Contract address. So what we do is equals to OX123 and try to up. So this should be it. So what 123 is actually is we're converting this literal value into an address, and because we know it might fail, I don't need to go into all this explanation. I guess you already know what it is. Const user. The type of contract address equal to -1234. That's 1234. That's into that's so this is us mocking the users, the people that are going to be using our contracts. So we have 3 contracts to deploy. We have the token sale contract, we have the mock token sale, It gives you token A and token B. So let's deploy those two functions. So let's do function deploy token A. So all we need here is we need the before we can deploy the tokens, if you remember perfectly well, they require a constructor argument of the owner. So both of them require constructor argument of the owner of the contract, the owner. So here, what we need to do is we say owner, which is a type of contract address, and then we return a type of contract address, which is going to be the address of the contract deployed. Right. We also need function deploy contract. Let me just give this one a random value. Okay. This is just a random value. Owner deploy token B. Also take the same argument. Owner, the type of contract address. If anything is unclear, please interrupt me so that we won't go too far without you understanding what is going on here. Let's try the user instead here. So this is just like we are setting up everything we need: function, deploy, potential contract, potential. It also requires basically the owner's constructor argument. Yeah, so the owner's constructor argument. Owner contract address. And return the type of contract address. Contract address. You can return the owner name. Yeah. All right. Then you can have a function called setup that deploy all of these three addresses, contracts, before we test anything. So what do we want it to return? We want it to return a tuple of different variables. We'll get to know why we need these things. We need it to return contract address, contract. Let's keep it 2 for now because we basically have just 2 variables. So let's return a total of user and owner. Sure, excuse me. So yes, that is basically what we have. But now let's go into the implementation of this function and take away this majority of the issue. So what contracts? So let contract equals to, this is where we use the declare function that we got from Starknet Foundry. We declare, what are we declaring? It usually take a literal value of the contract we want to deploy, the name of the contract we want to deploy. So which contract are we deploying for token A, which is a USDC sample. So we go back and say USDC sample. USDC sample. So it also comes with different functions. So let's unwrap it. Unwrap dot contract class. Contract class. So that is for the contract. Then we'll also do core data. Okay, let's core data. code data equals to what is the code data again? Our code data is going to be the owner and array of owner, an array of owner, right? Oh, yeah. Owner. Okay. Yeah, we are making use of the argument. Then we can actually now let once we call the deploy function on this particular type, this type of contract class, it returns a tuple. The first part of the tuple is the contract address. So contract address. We do not need the second value. So that's why we are going to ignore it. And now we call the contract variable contract dot deploy. So we give it the code data. Okay, this is span, which is a copy of the code data. Dot unwrap. So we unwrap because it also returns the results. Now we can return the contract address. Implicit return. And then our access code. And I don't like speaking line, but then if there's something I can just avoid, I will avoid it. So we do the same thing here. Let contract equals to declare. So what are we declaring? Token B. Our token B is block fuse log token. Block fuse log token. Dot unwrap. Class. So that is contract class. Or data was to array omega 20 and then we do the total contract choice and let's use contract one. Then we go back to the screen and confirm if anybody is following. Okay, wait. Right, so we pass it to span of the quantity. And then it's unwrap. Okay. Give it return the contract address. So that solves that problem too. For our token sales, we do the same thing. Just for the sake of time. It's just like a copy and paste of everything here. But here we change it to token sale. I believe it is token sale. Let's confirm the name of the contract here, token sale. So we change it to token sale. It is also taking the owner. So yeah, that is that. So here we call let's token A equals to deploy token A, and we give it the owner variable. Yep. Let token B deploy token B. Also give it the owner variable. Let's deploy token C. Let the token C. What should we call token C? Okay. What should we call? Let's say token C. In fact, let's change the name of this one. USDC block 6 token. Block 6 token. Then the same token contract. Let's token C to deploy token 0. Also take the owner. Then we can now okay. Since we have 3 addresses to return here, we can come here and say contract address. We have 3 contract address. Yep, we have 3 contract address. So now we can return a total of contract addresses. First thing, we need the token here. It is important. We have the USDC, then the block is token. So this works perfectly. Okay, another thing we can do is that since we need to initialize our contract before every other thing happens, let's initialize it here. Initialize contracts. So what do we need to initialize our contracts? If we go to our initialize contract variable, we need the 2 tokens, the tokens we are going to be buying and the one we are going to be selling. So we first have the dispatcher to interact with. So let's say let token show dispatcher. Show dispatcher equals to what's our token show dispatcher again? Hi token show dispatcher. So which requires our contract address. What's the contract address of token sale again? Token sale. Is that understood? So we've initialized our token sale. Then now we can now initialize the contract by saying calling the function on the dispatcher. Token sale dispatcher at initialize. So what do we need to give the initialization contract now? It takes payment token first, then sale token. Payment token is USDC, and then the sale token is block fees token. Is anyone following? Great. So yeah, those are the things we actually need to do to deploy. I think that should be it. That should be it. Now, here is where it gets interesting. We start testing uh, case by case. One of the most important things is we first test if we can initialize our contract successfully. So let's just do that. Let's test. Every of your test cases should be appended with tests. The first thing there should be tests initialization. We don't just need to assume that we can initialize in production. We want to confirm that things work the way they should work. Test initialization. So when we are testing our initialization, um, once we are testing our initialization, what we need to do, okay. Okay, do we need to do that? So what we need to do is to first, I think I want to don't want to repeat myself, and I don't want to assume we have already, okay, yes, since we initialize it, we do not need this one, so we just need to redo what we did in the setup. We assume the setup is not existing. Let's use this is supposed to deploy token here, right? Deploy token here. Deploy token here. That's it for now. It block field token. Deploy token B. Also takes the owner. And token 0. Equals to deploy token 0. Okay, so now let's token 0 dispatcher equals to I token 0 dispatcher, which is a contract address. This contract address of okay, so here now we call our okay token 0 dispatcher dot initialize. So we'll give it USDC and block fuels token. So upon doing this, let's test if we have initialized successfully. What assumptions should we test? What assumptions should we test? Let me go back to the code. In our code, Let me add something in our code so that we can test the assert successfully. Assert self dot initialization, right? Initialize dot read, sorry. Initialize dot read is true. Otherwise, not initialized. Not initialized. Initialized. So if we want to set rate and our contract has not been initialized, it is going to fail. We'll test the assumption too, that if we are going to initialize and we set rates and the contract is not initialized, it's going to fail. So here, let's do, okay, what do we do? Token sale. I do not want to jump the gun. I do not want to jump the gun. Okay. Sorry. I want to make sure we set out style by style. So if assert, usually data functions don't have data functions don't have assert query because they are getters, so there's no need for the majority of the text. But I want to edit this code so that we'll know if our contract has been initialized or not. Initialized. Okay. I mean this initialize dot read pairwise not initialized. So what I'm trying to do here is to ensure that if we call token cell dispatcher dot get rates dot get rates, it fails if it has not been initialized. But the assumption here is that since we have not set rate yet, we will assert that okay, let rate. We assert that rates is equals to 0, because if we have not set rate, the rate will automatically be 0. So that means the rate should be 0. Sure. So let's test that assumption. Yes. This is an important thing to note. Does anyone know why? I think I will do this here. So whenever I need to bring the text back into school, use the terminal, I do this rather. But does anyone know why we have 0 passed, 0 failed, 0 ignored? I do not assume you will, but let me see if anybody has actually gone ahead of the class. Can anybody attempt?
Sorry, please, what's the question again? The network is a bit breaking.
Okay. Yeah, the question is that we already have one test case, which is the initialization test case, right? But when we
Yes.
ran the test, it told us that zero passed, zero failed, zero ignored, meaning that no test case was run at all. So something important happened that we ignored, that we did not do. Every of your test case should have the external annotation tests. Test. So can we spot the difference now? One pass, zero failed, zero ignored. So the test case particularly ran successfully. So here we confirm that our initialization test case works successfully. So if we initialize and we call this function, it is going to actually run successfully. If we do not initialize, let's say this deep, how deep I'm going, it might affect how fast we run, because we have a few minutes left. But yeah, I expect this thing to fail because it means that we have not initialized yet. So you will see that the test will panic. You see that the test panic with a particular error not initialized. So this is exactly what will happen if we decide to interact with our contract without it being initialized first. So it is telling us that without initialization, nothing will work. Nothing will work. So yeah, let's go on. What about how to test after we have initialized? Let us set rates. With the rates also be the same tests function test rates, test set rates, test set rates. So here now let's just call our are we returning, what order are we returning this token zero? Token zero, UNBC log this token equals to setup. Remember, setup undo all of this for us. We do not need to do here everything here again, because setup will just deploy the contract and give us the initialize the contract before we do any transaction at all whatsoever. So we have setup, and now what we need to do is let's token to dispatcher equals to I token to dispatcher, which is going to take contract address token zero token zero. We have the dispatcher to interact with our contract now. So yeah, it gets interesting here because now we start doing what is known as cheats. The Starknet Foundry allows us the opportunity to use. There are so many cheats that you can use, and one of them is actually mocking different users. The distinction here is that whenever we run this test, the address of the sender of the person calling this particular function, this initialize function on our smart contract, is a randomized, is a generalized address that is for the whole token sale test scenario. But now we know that before we can test our set rates, it has to be the owner, right? So we need to mock the owner as the caller of that particular as the caller of that particular function. So Starknet Foundry allows us the opportunity to mock users. Start start cheat caller address here. Start cheat caller address. The other part is stop cheat caller address. Let's go to Starknet Foundry again. In the cheat reference, you find that caller address. Yeah, there's the caller address. So the caller address or cheat caller, start cheat caller address, where is it? Start cheat caller address cheat actually requires the target contract and then the address of the caller. So who is our target? What's the target contract in our case? The target address is our start cheat caller address. The target address is the address we want to call, which is the token sale, and the caller is who? The owner. So the owner is the one calling this particular call now. So we do token sale dispatcher set rate. And what rate are we going to set? So it is expecting a unit, so let's set it to 100. 100. One way for us to know if this works is that before we set the new rate, let us first get the old rate. So let's old rate equals to token sale dispatcher get rate. We need to assert that old rate is 0. Or we fill with rate as the set. That's the assertion. Compiler is giving issue. I was wondering whether it is giving us to the red line. So we stop cheat caller address. So when we go back here to check, what do we need to stop? The target contract, the contract we are calling. So we say token sale. Now we compare the new rate. Let's new rate as to token sale dispatcher. That's rate. So we assert that new rate is the same thing as 100 that we set on line 67. Otherwise, invalidate. Otherwise, we do invalidate. So let us test separate. It passed, right? Yeah, so it means that one thing about testing is that if this assertion is not correct, the test will fail. If this assumption is not correct, the test will fail. If this assumption is not correct, the test will fail. So meaning that we successfully set rate to 100 on line 67, and we assert that the new rate from the smart contract is now 100 on line 71. So that shows us that it passed successfully. So let's test buy token. Test function buy token. We do the same thing we have done here up until this point. We need this too, just to shorten our work. So we need this too. Then we also need we also need the dispatcher of the USDC. Let's USDC dispatcher goes to USDC dispatcher. The contract address is going to be USDC. USDC. Let's do the same thing for Blackfish token. Blackfish token dispatcher. Going to be Blackfish token dispatcher. It's going to take contract address, and it's going to be Blackfish token. So we have those three dispatcher now. So what we need to do next, okay. Yeah, I said you should interrupt, like on mute whenever you want to ask questions, so that my attention will be caught to it. But let me read the question and then. Sorry to interrupt you. This 100 does it mean when I buy Blockfish token, I get 100 Blockfish token per USDC? Exactly. So exactly. So it means the rate which the selling token is going to be exchanged for the buying token. So what I wanted to even do here is come here and do that. Okay, I want to bring this particular cheat into scope. You realize why you need this cheat, because it is going to help us shorten Okay, there's something I can do here to make this code look a little bit pleasing. Yep. Yep. So it made it easy for me to do this. And we also do stop checks. Stop check viewer. So when to buy, how we made here is okay, start check address global. Address global. For the cheat address global, the only argument we need is the caller address, which is the owner. And then we do number one, we set rates, because setting rate is very important. So, and then we do token sale dispatcher, that's set rate. You know why I'm hesitating? I am thinking we will need this set rate several times when we are actually testing any of the test situations. So maybe, just maybe, I shouldn't I shouldn't use the setup here and add, hmm, see, this is one of the essence of testing. You know why? From our code, anybody can initialize our code. That means they can actually just set the payment token or set token to whatever they like without any control. Do you understand that? Like that is a very dangerous scenario. That is one of the reasons why you test code to see if things are working the way they are. I realized that here we could actually just initialize, where is it, this line? We could actually just initialize the token without knowing whether it is the owner of the contract that is actually initializing the contract or not, which should not be. So while you are testing, you need to go back and forth with your contracts to see that, oh, this assumption is not the way they are. Self.owner dot assert only owner. So only the owner of our contract should be able to initialize the contract. Without that, we should not be able to initialize it. Because with this situation now, this is an attack vector. Anybody can change our payment token or say token to whatever they like. And it is going to brutalize our contracts. Sorry, no problem. Vulnerable. So start chief caller address. Only the owner. Now the owner can do this, and the owner can set rate. Set rate to 100. Most time, we tell you not to use magic number, because if anybody is looking at the test case, they'll be wondering what is 100. Most time, yeah. So just make sure that it is well known that let the rate of exchange, rate of exchange was to 100. So now we replace this with rate of exchange. So now what are we looking here? And then stop chip color address. Stop this here. So let's share this it. So here we do the same thing we did here for our set rate. For our set rate, so that we don't get it confused. In fact, we only need just one. Okay, so we'll be able to set rate. So back to this situation. We do not need to set it again because it is going to be set in the setup function. And now we can now do we need to mint to the buyer, mint token to the buyer. So now we do what is the buying token? The buying token is USDC. So we do USDC dispatcher dot mint. Who are we minting to? The user. Then how much are we minting to the user? Let's say 10,000. We also need to mint to the contract. Mint sales token. Sales token equal to the contract. So here we do block fields token dispatcher. Block field. What are we minting to? We are minting to token sale contract address. Token sale contract address, and how much are you minting? Let's say 100,000. 100,000. So we minted 100,000 to the token sale. Now we can stop chip color address global. I don't know, so we can stopping chip color address global takes any arguments. Yeah, it doesn't. So yeah. So in this situation, we have this. Now we can now mimic the buyer. Let me mimic the buyer. The buyer, let's say, let's I want this to be descriptive as possible without being extraordinarily long. Let's user balance of sales token before purchase. That's long. Okay, say token user balance. Balance before purchase. Before buy equals to let ERC20 equals to IERC20 dispatcher and ERC20 dispatcher contract address, which is going to be, we want to check their block fees token balance. To check their block fees token balance. ERC20 seal. Auto ERC20 seal. Balance house. Balance button, the user. So assert that yes, sales token for balance. Sales token balance for branch equals to 0 because they must have 0. They must have 0 as at this point. Now we can make them that the device starts cheat color address. It is you can say it is the target contract and the user is the caller. So we now say token share dispatcher and by token, right? By tokens. By tokens. So when we call buy tokens on that contract, it should give us it is expecting the amount of token to be spent. So let's say 10. I want to buy with 10 token. Top cheat color address. Token sale. So now we can now check post buy. How much token do they now have now? Let's say I will just copy this line to shorten my now it's going to be set token after buy equals to 10. Sales token after buy. No, it is not going to be equals to 10. Do you know why? Because it is going to be whatever amount they send here times the exchange rate. And don't forget the exchange rate is how much again? The exchange rate is where is it? The exchange rate is 100. So we are going to say equals to 10 times exchange rate. Oh no. Oh no. Oh no. Times okay. The easiest way to do that should be not to make the code too long. If we are actually going to be using this code, there is going to be a lot of rewriting that we'll do. Go to it. Wait, in my get rate, how was I doing again? I think I was doing assert, right? And that should not be. Okay, yeah, I was not doing assert. So get to it. Let's say balance period, balance not change. Balance not change. So it is supposed to be the token after they have bought is going to be the amount they buy times the rate of exchange. So let's test that assumption and see if it works. Function tests by token. By token. No. It will not work. I just noticed something. Why did you ignore it? Why did you? Yes, exactly. Why it will not work? I know if I ask questions, there might be answers, but the reason why it did not work is simple. We did not approve the smart contract to transfer token from the user, which we actually need to do. So we can change this to global. Let's change this to global. Remove the token cell. Remove the token cell and add global to this one because we want the user to call more than a contract. Whenever you need to mock the user calling more than a contract, you change it to global. So here, the first contract we need to call. We also need let's E and say 20 buy token buy equals to I E and say 20 dispatcher contract address of USDC. Okay, let me put it. My test. Let me start here. We will now say ERC20 by dot approve. We are approving the smart contract, which is the token sale to spend 10 token, which is the amount to buy. Now, we have used this 10 several times. So why don't we just abstract it into a variable and say let by amount equals to 10. So we change this to by amount and by amount. Can we stick together? Okay. So yeah, that is what I'm expecting. Now our test should work. So without approving the smart contract to spend money from the user, the test will not work. If we go to our function in the buy token, we are expecting transfer from anywhere you see transfer from. There has to be an approval given ahead before this function is called. Because you cannot transfer from anybody who has not given you approval to spend your token. Test buy token still returns insufficient allowance. Test buy tokens. Insufficient. We will be done. Let me separate this. Just like this is yeah, this is so give me the to potential that's what it allow to this so like should have similar Yes. So our test passed, and this confirms that our shell token, our buy token function actually works the way it's supposed to. Because here at line 104, here, we have not buy this, we have not interacted with the contract, we have not bought the block fuse lab token at all. So our balance here is 0 at line 104. If it had not been 0, this test would have failed, because any number other than 0 means that we have already bought. And then on line 115, we confirm that our balance now, the balance of the user, has changed from 0 to the amount of what we bought times the rates of the exchange. Is that part clear? All right.
But sir,
Yeah, I'm with you.
so why are we approving with an extra token?
Yeah, I'm just playing safe. You understand? If we do not do the extra token, it's going to give all the same results.
Okay, because I was wondering, so if we continue to approve with an extra token, it's going to mean that it is going to continue compounding, and the contract is always going to have an approval that the user might not necessarily want to give at a particular moment.
That
So,
is,
and also,
yeah, I'm with you.
yeah, and also, I was wondering why we should not just test with the actual value so that we see whether it works or not.
Yeah, I'm testing with the actual value now, which is supposed to work. Yeah, but I totally understand you, and that is the design I usually optimize for too whenever I'm testing smart contracts or whenever I'm even writing code at all. Are you following? What is currently obtainable is not ideal. A lot of people just want unlimited approval. That's what you see majorly. You see, when they tell you to approve, you are approving unlimited amounts to the contract. Are you following? But for me personally, I only want the actual amount that the contract is dealing with from the user to be approved, so that there's no scenario where in the future where you might have malicious mind to go and now spend users token without their consent because they have already given you approval for more than you need. So now look at what we did now. We removed the extra token here, and the test worked perfectly. Are you with me?
Yes, sir. Yes, sir.
Yeah, but why the test failed earlier on? It said something about insufficient allowance. So that was what got me curious. Okay, to see whether I should add one more and see if that is the case. But that is not the case. The case was that when we were initially doing it, we were lumping. Sorry, we were lumping these two functions together, this approve function and the buy token function. So meaning that the cheat caller cheat did not identify this as two different contracts entirely. So once we separated it, the token the smart contract got approved to spend the token first, and then the user called the buy token on the smart contract. So as you mentioned, the best way is to make sure that you are only spending or you are only approving the exact amount that the smart contract need to spend from the user. So let's test the cell token. I think we have cell token, right? We have cell token. Where is it? Cell tokens, yeah. Let's test our set tokens assumption. Just English. All right. So we need the setup from here. basically, and I forced to just copy this to save time so that we'll be able to answer some questions before the time run out. We only have less than 10 minutes left. And you will have assignments. So yeah, here is what I'm hoping to do currently. So we have got the setup. We initialize the dispatcher, this thing. So we have 20 sales dispatcher. Now the user is going to mint the owner. The owner is going to mint USDC to the contract instead. I hope that is understood. Or instead of doing that, let's mint to the user too. Yeah, let's mint to the user. So we mint 10,000 to the user. We mint the token to sell to the buyer, to the smart contract rather, 100,000. And we have the amount to buy, sell amount. Sell amount. This should be 1,000 because we want to return. Oh, yeah, buy amount. We need both. We need both buy amounts. Sell amount. Let's sell amount equals to buy amount times token sale dispatcher. Token sale dispatcher. Token sale dispatcher dot again. Identifier is there. Dispatcher dot get rate. Get rate. So the balance of the user, this remains the same. We approve. This remains the same. This remains the same. All up to this one. This one should not be same amount. Same amount. And then now we test. Just sold back of was bots. So now we make the user that change color address. Token so user and then say token so dispatcher. So sell tokens. Oh, okay, we're not selling. You are selling the sell amount. So that is what we bought. What we bought here. Data of what we bought is what we are now selling back. And then check something on the contracts. Yep. We also need to approve. First need to approve that here it says 27. Approve. Who do you want to approve? Putting through format, same amount. The target here is now the block field lab token. Block field token. Block field token. So we approve and then we stop the color address block field token. Then we start with color address. It shouldn't be this long. Just that I want us to buy first and we sold exactly what we buy. Instead, we could have just tested directly with different assumptions. So, token zero, yes, token zero, include stop. Yeah, okay, step. Now we only need to confirm that our balance has changed. How do we do that? Let's use a balance before sold equals to EMC 20. EMC 27. Balance of area asset that user balance before selling equals to into this one equals to sell amount. We also going to say now let user balance after selling equals to actually going to sell balance from user assets user balance after selling equals to 0. So this is what it should be. So once we have sold back, Once we have sold back, the balance should be 0, and we can as well test. You can as well check if the amount of their USDC also change, because they are supposed to get USDC back. So from here, you can also assert you can also assert and say with USDC, USDC balance before billing equals to, yeah, say 29.12 user. So assert that user USDC before selling is equals to looking for the best assumption to use for this. Looking for the best assumption to use for this. Okay. I think the best assumption to use should be how much did we mint to the user earlier? We minted 10,000 to the user. So it is going to be, let's say, 10,000. And now some buy amount, or what do they call it? Okay, buy amount. Minus buy amount. So to test the assumption after, before selling, test the assumption after, we do user balance after selling, after selling, after selling, after selling is going to be now be let's say this balance before selling loss by amount. Is that understood? Alright. It has my PC frozen. Ah, thank God. I thought I was speaking again for a while. Okay, so let's check that out. Yeah, test, start test. So the police. Oh, oh. That's it. That's it. It did not fail. That means the compiler actually picked this up before it compiled the test. Interesting. So yes, all our assumptions are correct. The user balance before selling back shows that the amount they used to buy minus the total amount remitted to them is there because they have already bought up there. So they bought it this amount, so it should be minus this. And after they sold, their USD balance is the USDC balance before they sell plus the amount they bought initially. And also the token they got when they bought, which is the user balance before selling, is the same thing as the sell amount before they sold. And after they sold, it is now going to be zero because they sold back everything they bought. So yes, that also works correctly. So yes, that is all for today. There are so many other functions to test, but time will not permit us to do that. So that will be your assignment for you to be able to test the sell token, get token out, withdraw payment, withdraw save token, get payment balance, get sell token balance, withdraw payment token, all of these other functions. So you need to test them and submit the assignment. I don't know the structure of your classes, whether there is a general repository where I can push this code to for you to put locally and continue testing, or I should push to my own repository where you can pull from and continue the test. Yeah. So guys, that will be the end of the class. If you have any question relating to testing, first testing or whatever testing, you can always reach out to me through my account. You can meet Scarface to reach out. So I will give you my WhatsApp contact too. Yeah, so thank you for joining the class, and I hope to see you guys building amazing product on Starknet.